Hello and welcome back. Now we have modeled our goalpost frame by typing in the joint coordinates and the member incidences, once directly in the text editor and on the other occasion in the graphical user interface in the node table and the member table. Now in this video we will model the same goalpost frame, but on this occasion we will use the construction grids. This is especially helpful when the structure that you are modeling is large. But before we go into that, please take a moment to hit the subscribe button and join us in this wonderful journey of learning structure analysis with STAAD.Pro. Today we'll talk about construction grids, about constructing the construction grids. The actual modeling of the goalpost frame will be done in the next episode. So, what are these construction grids? Well, a construction grid is a set of imaginary lines drawn for the purpose of assistance in modeling, and those lines crisscrosses each other at right angles, thus forming a grid. The engineer may give a convenient spacing to the lines so that it would assist in his modeling work. To specify a construction grid, in order to create a new structural model, we need to create a new STAAD file. And once you are in the new STAAD file, you need to ensure that you are in the analytical modeling geometry option. If you are not in that mode by any chance, you just need to click on these options to be in that particular mode. And once you are in the analytical modeling geometry mode, you need to go to the grid options from the main ribbon menu and select or click on the switch that is below that option. As soon as you click on that switch, it would display a couple of grid options. So you need to select the first option, the beam grid. Now, once you click on that option, you would see that a snap node beam dialog box has been displayed on the right side of the screen, and there is the name of a default grid in that particular box. The corresponding default grid is being displayed in the viewing area, as you can see, and it's a set of imaginary dotted lines that would help us create our structural model. You'd also notice that by default, the view of the grid is isometric. However, let us not use this default grid, but let us create a new grid in the XY plane which has 1 meter of spacing in the X direction and 0.5 meter of spacing in the Y direction. Again, the purpose of this exercise is not to solve any modeling problems with this construction grid, but we want to focus on what are the various parameters that we need to focus on to generate the construction grid. So before creating the construction grid in STAAD, let us explain a few inputs related to the same. The first thing that we need to define is the plane in which the grid will be created. So our first parameter is the plane in which we need to define the grid. So our first parameter that we need to define is the plane of the grid. And since we are creating a planar structure, the plane of the grid would be, you have guessed it right, it would be the XY plane. Now, the next parameter, there is another parameter in STAAD which is called the angle of the plane. The angle of the plane. But for now, in this course, we would choose to ignore this input. So let us ignore the angle of the plane because we don't need to define the angle of the plane for the structures that we would be modeling in this particular series. The next thing that we need to define is the grid origin. The input of this parameter can be given in two ways. One is where we can define the coordinate of the grid origin, the global coordinates of the grid origin. That's number one. Or we can refer the grid origin to an existing point in the model. But in this case, now since we are creating a new structure, so we would not have any existing point. So we would need to define the grid origin as coordinates. For our purpose, let us define the grid origin as the global coordinates of the origin of the global axis system. So then the grid origin, we will define that at coordinates 0, 0, 0. And as I've said, these are nothing but this point would also represent the origin of the global axis system. The next thing that we need to define is the number of divisions. Okay, so now since we will be defining this grid in the xy plane, so if this is x and this is y, so we need to define the number of divisions of the grid in the along the x-axis. So number of divisions is another parameter. So there are two divisions to this again, or two aspects of this. One is, so if this is the grid origin, we can define the number of divisions to the left for along the x-axis. Okay, so this is number of divisions along x-axis. So there can be two things. One is that, so if this is the grid origin and this is along the x-axis and this is the y-axis, this is, we are saying this as the grid origin. So we can define the number of divisions. So this would be the left of the grid origin and this would be the right of the grid origin. Okay, and similarly this would be above the grid origin, right, along the y-axis. Along the y-axis this would be above the grid origin and this is below the grid origin. Okay, so our requirement is number of divisions along the x-axis. Let us have 5 divisions along the x-axis, 5 divisions at the left. So we'll have 5 divisions, and on the right of the grid origin we will have 5 divisions, and both would be at a spacing of 1 meter. Okay, and then we will have also need to specify the number of divisions above the grid origin and below the grid origin along the y-axis. So number of divisions along y-axis. What would be the number of divisions along y-axis? In our requirement, as per our requirement, we do not need any division below the grid origin. Okay. Now, an interesting thing to note is that in STAAD you will have the term left and right only. Left and right is clearly understood when it's when you see that in context along the x-axis. But when you see that along the context of y-axis, left and right won't be understood. So for this, let me tell you that left would represent below the grid origin, and that is along the y-axis, and above would represent the right of the. So in case of divisions, specifying the divisions along the y-axis, we do not need any divisions below the grid origin, so we will not have any divisions in the left, but we will have 10 divisions. We want to have 10 divisions above the grid origin. So for right we will have 10 divisions, and the spacing that we want to give for these divisions would be at the rate of 0.5 meters. So the divisions would be at a distance of 0.5 meters. Now, what would this mean? Now, we will actually end up with a grid something like this. Let me try and explain. Now that we have understood the basic concept of generating a construction grid, let us go into STAAD.Pro and define the same. So let us click on this create button here to create our new construction grid. So we click on this create button, and you would see that a box would open where all these parameters that we have been discussed has been mentioned, and we need to input those parameters in this particular box. Let us start with the type of the grid. Right at the top, you'd see a small switch here. So if you click on here, you'd see the various options of defining grid as linear, radial, and irregular. But for now, we are defining linear and regular grids only. So we retain the option as linear. We need to give a name to the grid system that we're creating. So we name this as grid_1. Just at this point, I just wanted to reiterate that the grids are nothing but a set of imaginary construction lines that helps us in creation of the structural models. Now, these are not real lines or real members. Okay, now let us go on and define the various parameters that we have already discussed. The first is we have to specify what the plane of that grid system is. So as we have discussed, it would be XY. We do not specify anything for the angle of plane. For the grid origin, we retain the coordinates as 0, 0, 0. So thus the grid origin is same as the origin of the global axis system. Now, we have talked about how we want to define our construction lines. We wanted to have 5 divisions on the left of the grid origin along the x-axis. So we specify 5 for this. We wanted to specify or have 5 division on the right of the grid origin along the x-axis. So we specify this as 5. The spacing between the grid lines was supposed to be 1 meter. So we retain this value as 1. Along the y-axis, however, left and right would appear a bit confusing. Just to explain that, left is nothing but the bottom or the below, or it represents the number of divisions below the grid origin, and we have said that we do not want to have any divisions below the grid origin along the y-axis, so we retain this as 0. We wanted to have 10 divisions above the grid origin. Now this above the grid origin is represented as right, okay, along the y direction. So we wanted to have 10 divisions above the grid origin along the y direction. So we specify this as 10. And we wanted to have the spacings of the lines as 0.5 meters. So we wanted to specify 0.5. Now we are ready with, as we have defined all the various parameters required to create our new construction grid. So we click on the OK option, and you would see that our new grid name has appeared below the default grid name in the Snap Node Beam option. To view this particular grid, we just need to select this checkbox besides our grid name, grid 1. So we select on this box, and you would be able to see the grid that we have created on the viewing area of the screen. And as you would also notice that the view of this grid is isometric by default. In the forthcoming video, we will continue to examine the grid for its properties. The modeling of the goalpost frame will be done in the video after that. So if you have liked this video, please hit the like button and please press the bell icon for more notifications from this channel. See you in the next video. Till then,